All right, so we're going to look at line and segments that intersect circles. So today's notes is just a lot of vocabulary. Okay, it's not necessarily hard as much as once you understand the vocabulary. All right, hence why we're giving you the vocabulary test, right here next to it. Okay, so your vocabulary list that you have has all of these definitions on it. Okay, so let's just look at this. Some of these you've already seen, you already know about. Like y'all said, a radius is from the center to the edge, right? Okay, we looked at that in our warm-up. Radius is from center to edge. So no matter where I look at a radius, is it going to matter? Like, is it going to be the same length no matter what? Yeah, radius is always the same, from the middle of it to the edge of the circle. Okay? Now, one that you might not have heard of before is called a chord. C-H-O-R-D, chord. It is not chord, it's chord. Okay? And what that does is it goes from the edge to the edge like that. Okay? What other one goes from the edge to the edge? Nope, not secant. Diameter. Okay? It goes from the edge to the edge like that. Okay? These are segments. That means they have beginning and end points. But what do you notice different about a chord and a diameter? Where does a diameter go through? It goes to the center, okay? That's what differentiates a chord and a diameter. Technically, a diameter is still a chord, right? Because it goes from the edge to the edge. But it's just like, I guess you could call it like a special kind of chord, all right? It's a chord that goes through the center, and that's what makes it a diameter, okay? So a diameter is a chord. The diameter, this can be a chord, the diameter, but not all chords are diameters. Okay? All right, the other one I see here is the tangent line. Okay? So the tangent just kind of grazes on the edge of that circle. And basically it intersects at one point. Okay? So that's how I remember it. It just intersects at one point, grazes along the edge of it. Then the last one here on this one is secant. When you look at that, those first three letters, S-E-C, what other word comes to mind that starts with S-E-C? What is it? Second, right? If I get second place, what number is that? 2, right? So a secant line intersects a circle, the edge of a circle, twice. Okay? So think about second place, number 2, secant intersects 2 different times. Okay? So tangent intersects once, secant twice. All right? And I did forget to mention this one a while ago. Like on this little circle here, see how this little tangent line running along the bottom? This point right there, point B, where it intersects the circle is called the point of tangency. Okay? All right. So let's do some examples of this. So on this page, go to this part here. We're going to go a little bit out of order because I'm going to explain one part, then we're going to do some examples with it, and then move on. And then go to the other part and then do the examples with it. So it says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. You want to make note, see this little symbol here? What do you think that represents? A circle. Okay, I think I heard somebody say it, circle. Okay, so this is the circle symbol. All right, and then the letter C there is a point on the circle. When you look at the actual circle, where is C at? The middle. Okay, so this is my center point. Anytime you name a circle, you put the little circle symbol, and you pick whatever the center point is what its name is. Okay? So just think about that center point always stands out on a circle, right? It's right in the smack dab in the middle. That's the one you use to name it. Okay, so the name of this circle is circle C. All right, so let's look at this. Letter A says, find the length of segment AC. So remember, a segment doesn't have arrows on it. Okay, so basically they want from A to C right there. Okay. Class, do y'all think that's a radius, a chord, diameter, secant, or tangent? Radius, right? It goes from the center to the edge. That's a radius. So let's label it radius. And a radius will always be a segment, right? It has a definite starting point and a definite end point. Okay? Next one, AB. Goes from A to B. Which one on that do y'all think that one is? Diameter. Okay? So how do we know that's a diameter versus choosing it as a chord? Yeah, it goes to the middle, right? Okay. So it's a diameter. If it helps you remember, a chord, a diameter, radius will always be a segment. Okay? So they're never going to be like a line or a ray or anything like that. So all these symbols that we learned at the very beginning of the year, they all come back here. Next one, letter C. What's that symbol above DE represent? A what? A ray. So it's talking about ray DE. So that's saying from D going through E and going all the way like forever that way, right? Okay. What do y'all think that one is? A tangent. Why do you think it's a tangent? Yeah, okay. Heard multiple people say it only intersects in one point. And what is that point that it intersects at? At B, right? So it's tangent. And then the last one. AE. What's that symbol above AE tell me it is? It's a line. And a line goes on to infinity in how many directions? Both of them, right? In two directions. So AE. So that's A goes through A, through E, like that, right? Okay. What do y'all think that one is? Secant. How many times does it intersect? Twice. Yep. Secant, think of second place, number 2. Secant. Questions on that? It's not too bad, right? Okay. All right, now this one, instead of giving you something, they want you to name 2 of them. Name the stuff off of the drawing. Number 1 says name 2 radii. What is radii? Yeah, it's a plural for radius, right? So if I just want the radius, I just want 1. If I want radii, it's 2 or more, right? Like goose and geese. We don't say, I have 5 gooses, do I? No. So you don't say, I have 5 radiuses. Radiuses, right? No, we say we have 5 radii. Okay? 2 radii. So somebody raise your hand. Lainey, tell me one. AF. So from here to here. Do y'all agree, class? Yeah. AF. What symbol should I put on that one, class? A segment symbol. So should it have arrows? No. Just AF, like that. All right, someone else raise your hand. Tell me a second one. Jada? AB? Y'all agree with that? Yeah. And same thing, it's going to be a segment, right? Okay. Does anybody see the third one? Yeah. AD, segment AD, right? Okay. Anywhere from the center to the edge of the circle. All right, number 2. Name a chord. Someone raise your hand. Lester? Which one? DE? Do y'all agree, class? Well, it depends. What symbol goes above it? A line? So you're saying like this? Is that right? No. It can be right. But what does a chord have to always be? A what? Segment. Okay. So if we take 2 arrows off, I know that DE there, the whole thing is a line. But remember, you can pull out a segment out of a line, right? And you can say just from D to E is a chord, right? Okay. What's the other one? Other one is CE, right? So you can always put CE as well. Okay. What is the third technical chord as well? DF. Okay. But DF is also the what? Diameter. So remember, the diameter is a chord as well. So you could technically say DF for a chord. But we just said the diameter is DF. What symbol does diameter need to be? Segment. Right? Okay. All right. Number 4. Name a secant. Somebody raise your hand for that one. Jermichael? DE. Okay. What symbol goes on top, though? A line. So how many arrows? 2. So good. This is a good example. You see how number 2, when we made DE a segment, we said just from point D to point E, it starts and stops with those. That means it's a chord. But if it goes on forever and it passes through those 2 points, that makes it a secant. Okay? All right, 5. Somebody hasn't answered yet. I'll start cold calling if y'all don't. Okay, Damien? Oh, I'm sorry. You're right, yes. Y'all add, there's a missing point. There's supposed to be a point on here. Add G to that line with B. So it's going to be what now? BG. And what symbol? A line symbol. Okay. So BG. Now, like on your homework or whatever, you can't just add points when you need to add points, okay? We did this because it's missing one. It's supposed to have one there. All right, and last one. Class, anybody can say it. What's the point of tangency? Point what? B. Okay. Do I need to put any kind of symbol for point B? No. What word could I put if I wanted to in front of it? Point. Okay, I could literally write the word point in front of it or just put B and it's the same thing. All right, so not too bad, right? It's just like I said, it's just learning the definitions. That's the hardest part about this section. All right. So let's go back to the top. Coplanar circles and common tangent. Does anybody remember what that word coplanar means? Perfect. On the same plane. Okay. So like, remember when we drew the little plane and normally it's like a little rhombus or something looking thing? And it like we'd say all the points that are on within it were coplanar points. Same thing. It means these circles are on the same surface. Okay? And so any circle that like just intersects one time with another circle is called a tangent circle. So for example, if I had a circle here and another circle and they just intersected one point, that would be a tangent circle. Okay? All right, and then circles that are have a common center, mean their centers match up, are called concentric circles. And they have a picture of it there. All right, but there's multiple ways that a circle can intersect. So this first one is 2 points of intersection, okay, where it overlaps each other. Where do we see this in real life? 2 circles overlapping like that? Okay, compare and contrast. What is that diagram called? A Venn diagram, right? Yeah, like so y'all use compare and contrast. In the middle of it would be the things that are saying they share in common. And then in the actual, the other parts would be what's different, okay? All right, so that's 2 points of intersection. So tangent circles that we talked about with 1 point of intersection. Where could we see this one on the left in real life? Where it's like there's a bigger circle, the smaller circle in it, and they're touching just at 1 point. Where do you think you could see that? It looks like a what? A hot air balloon? I'm not seeing it. Huh? Can you explain it? No. Did you say something else, Damien? An eye? Okay, so like maybe like the pupil of the black of the eye will be kind of like a little bit lower. Okay. Anybody else have one? This one's a little harder. Third period, we came up with a flat tire. Like when your tires, because somebody said a tire, but I'm like, I think your tire's not right if it looks like that, right? Okay, the rim's supposed to be in the middle. But if you got a flat tire, then one part's, touching, the rim's touching the bottom of the circle there, okay? All right, what about this one right here? Where do we see that in real life? So a snowman, right? Okay, we just had a snow day not too long ago, right? So when you're drawing a snowman, typically you draw them just touching like that, okay? Another one is gears, right? When you have a gear train and you have two like gears that have the teeth and they touch at one point, okay, and they spin each other. All right, good. All right, no points of intersection mean their edges never touch. Where do we see these on the left here that aren't even touching, like not even close? What's that? Planes? Planets. Oh, planets. So yeah, if you're drawing planets, okay. Eyeballs, right? Okay. Well, I mean, yeah, maybe they're not right, okay? Like you could have, they could be the same size drawn, so same size. Okay. All right, what about those concentric circles that share the same point? Where do you see stuff that looks like that in real life? A target, right? Okay. A dartboard, a target, something like that. That's an eye. Okay. Somebody who has a perfect eye, right? Solar system. Okay, so like with the sun in the middle and everything, orbiting around the sun. Okay, good. I like it. All right, so let's go to the back and we'll talk about common tangents. It's easier for me to just talk about, like show you what common tangents are rather than just try to explain it. But let's think about it. A tangent intersects in how many spots on a circle? Once. So a common tangent, basically what it says is that like it intersects two different circles one time on each circle. Okay? So let me work number 7 with you so you can see what that looks like. Says, tell how many common tangents the circles have and draw them. So I'm going to give you an example of what would one look like. Draw a line across the top and have it only intersect each circle one time. So you see how that tangent line, it's a tangent to both circles. It only hits each circle one time. All right, where could I draw another one at? Okay, across the bottom. Now, obviously, my drawing's not perfect, so it looks like it intersects it multiple times. Y'all see anywhere else where it only intersects one time? Okay, so let's see. If I do the side, you talking about like here? Does that hit both circles one time? No. So that's a tangent line, but only to one circle. Okay? A common does both. Like this. Does that intersect each circle but one time? How many times does it intersect each circle? Twice, right? So that would actually be a secant. What's wrong with this one if I just drew it like that? Yeah, so I only drew it to intersect only one time, right? But a line, does a line stop? No, so it would extend into the outside edges as well. Okay, so these are only two we can do on that one. So this one's just going to be 2. And then we ask the question, are they internal or external? Internal is where? What does that mean to be internal? Inside. External is outside. Okay? So what it means is basically, are they in between the two circles? Or are they outside, or like outside of the two circles? So what do y'all think these are? Are they outside? Yeah, so they're external, right? All right, next one. So if you have two different colors, I would do this with two different colors. It says use red and blue. I don't care what two you use. Tell how many common tangents the circles have and draw them. Use blue to indicate common external and red to indicate common internal. All right, so let's do the blue first. So the external. On letter A, where can I draw an external one? Okay, across the top. Anywhere else for external? Across the bottom. Okay, anywhere else external? Okay, so if I go in between, that's going to become internal. You're right, but that'll be internal. Any more external before we go to internal? Okay. So Annika said in between at a diagonal like that. So that's in. So you see how those are in between the two circles? That's what makes them internal. Is there another one we can draw internal? Yeah, just go the other way diagonal, right? Well, that's kind of bad. So it doesn't matter if they cross other lines. What matters is how many times they intersect the actual circle. Okay. Do y'all see anywhere else we could put any kind of tangent? Common tangent. No, that's it, right? How many we got there? 4. Okay. All right, letter B. Where are my external ones on B? Yeah, the top and bottom, right? I'll try to draw that. Okay. Now, do I have any internal ones? In between, so you're talking about like this? All right, yeah, that only intersects because those circles are just touching at one point. Those only intersect at one spot. Any more? Nah, that's it. And letter C is just like the one above, right? So it doesn't have any internal, just 2 external. There. And there. So 2. Any questions?